Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to continue the power series topic. And this time, we are going to take cases that are not trivial. What I mean by that is that the interval of convergence is not a single point, and it's not the whole thing from negative infinity to plus infinity. I prepared like 3 examples here to go over with you and see how we determine, the interval of convergence. So when we start with a problem like that, we see right away that the center, remember, the center is the value of x that would make the quantity between parentheses equal 0. Why? Because if I keep adding a series of zeros, 0 and 0 square and 0 cube, I will always get 0, right? So we know for sure that the center of convergence is -3/2. And then we calculate the radius and see. If the radius is 0, then this is the only point. If the radius is infinite, then we get the whole spectrum. If it's somewhere else, something else, we will add the radius and subtract it. Once added, once subtracted to get the limits of that interval. And then we have to check the two endpoints. Do we include them or include only one of them or don't include any? So we said, as usual, we are going to use the limit of, I don't need a calculator. It's just bothering me. A limit comparison test. And the way we do it is that we take the limit as n approaches infinity of the absolute value of un sub 1 or the next term over u sub n, which is the current term, and make sure that this value is less than 1. Why less than 1? Again, because that's how your series will converge. Any geometric series will converge if the multiplier or the absolute value of that r is less than 1. Okay, so let's do that. -1 to the n plus 1 over n plus 1 times x plus 3/2 to the n plus 1. And then we divide by the current value or the current function, which is -1 to the n, x plus 3/2 to the n over n. So again, as we always do, we are going to see that this cancels with the n. So you get x plus 3/2 on the top. If you divide this by that, you end up just with -1. Notice we are taking the absolute value, so you won't get anything else. And finally, you take the limit of n over n plus 1. Notice that this limit goes to 1, right? And again, if you don't know, you can divide top and bottom by n. So the numerator would be 1, and the denominator would be 1 plus 0, which is 1. So this limit is 1. So now we say that x, or the absolute value of x plus 3/2 should be less than 1, meaning x plus 3/2 is greater than -1 or less than positive 1, right? And then I'm going to subtract 3/2 from everywhere. So you get -5/2 is less than x is less than -1/2, right? So that's the interval of convergence. First of all, my radius is 1, and my interval is -5/2, comma, -1/2. And I only thing remaining now is to find, do I use parentheses or brackets? So we check. If x equals -5/2, let's go to our original power series. The summation n going from 0 to infinity of -1 to the n over n times -5/2 plus 3/2 is -1/2. I'm sorry, is -1. Why did I say? So times -1 to the n. I have -1 to the n times negative 1 to the n is 1 to the n, right? And 1 to the n is 1. So what do we get? Remember what I said last session? We get the harmonic series. You don't have to prove anything. You say it diverges. So this is a parenthesis. See how easy it is? Now, if x equals negative 1/2, my summation would be summation n going from 0 to infinity, negative 1 to the n over n as before. And if this is negative 1/2, and then you add 3/2, you get 2/2 or 1 to the n, which is 1. Meaning I would be just left with that. What is that? The alternate harmonic series, and this one converges. Remember I told you that these two are very important. We encounter, not always, but we encounter them many times, that it's good to know. And that's it. So we found the center, we found the radius of convergence, and we found the limits or the interval of convergence and whether the two endpoints are included or not. So far, so good? Let's move to the second example. The second example is negative 1 to the n, summation n going from 1 to infinity, of 3 to the n over n root n times x to the n. Seems complicated, right? Doesn't matter. We are going to take the limit as n approaches infinity of the next term, which is negative 1 to the n plus 1 times 3 to the n plus 1 times x to the n plus 1 over n plus 1 times root of n plus 1. And then I'm going to divide by this, which is negative 1 to the n, 3 to the n, x to the n, n root n. And I want this limit to be less than 1. As always, x to the n and x to the n plus 1 would leave me with x on the top. 3 to the n and 3 to the n plus 1 would leave me with 3 on the top. Negative 1 to the n and negative 1 to the n plus 1 leaves me with negative 1 on the top, meaning I have negative 3n root n x over that. So now I want to take the limit of n root n over n plus 1 root n plus 1. And you can see that the limit here is 1 again. How do you find the limit? If you get infinity over, you don't need to use really L'Hopital's rule. All what you can divide, say, this by n and this by n, and then this by root n and this by root n. The root will go inside the root, so you get basically this is 1, this is 1, this is 0, so 1 plus 0 is 1, and now this is 1, and here you have root. This would be the square root of n plus 1 over n. So again, you apply the same logic. You divide top and bottom by n. You get 1 plus 0 over 1 is 1. Square root of 1 is 1. So it's 1. Okay? So I know that I have negative 3 times 1, because the limit is 1. So you get negative 3 x. First of all, we forgot to say, or I forgot to say, that the center is at 0, right? Now, I want the absolute value of negative 3x, which is 3x, to be greater than negative 1, less than, or I'm sorry, the absolute value to be less than 1, meaning negative 3x should be greater than negative 1, less than 1, or if you multiply by negative 1, these would reverse, but the 1 becomes, it stays the same, so to speak, is greater than negative 1, less than 1. And then you divide by 3, so you get x is greater than negative 1/3, less than 1/3. So I know the radius is 1/3, the intervals or the interval of convergence is negative 1/3 to 1/3. And again, the only thing remaining to be found is whether these two values would be included. So we'll go back and say if or when x equals negative 1/3, I will get summation and going from 1 to infinity. Notice here we started the series from 1, not 0, because I divide by 0. That will give me infinity, so it won't work. Or in fact, yeah. So basically what we have here is negative 1 to the n times 3 to the n over n root n times negative 1/3 to the n. Negative 1/3 to the n times 3 to the n is negative 1 to the n, right? The 3 and the negative 1/3, when you multiply them, you get negative 1. But negative 1 to the n times negative 1 to the n is 1. So I will get the summation and going from 0 to infinity of 3 to the n, I'm sorry, is of 1 to the n, which is 1, over n root n. Does it converge or diverge? It definitely converges. Why? Because that's a p series with p greater than 1. If that was 1 over n, it will diverge. That would be the harmonic. But if this is 1 over n to the 3/2. 3/2 is more than 1, so that series converges. So I use a bracket. When x equals 1/3, I will get the summation and going from 1 to infinity of negative 1 to the n, 3 to the n, 1/3 to the n over n root n. This times that is 1, right? 1 to the n is 1. So I get summation and going from 1 to infinity of negative 1 to the n over n root n. Again, it converges. You know, like the alternate test, it says if the term that you have is continuous, and this one is continuous, and if it's decreasing as you go one term to the other, yes, it decreases when I increase n, because that would remain either negative 1 or positive 1. And if the limit of that goes to 0, yes, it goes to 0 if you substitute, then it converges. So this one converges. Okay, this will keep alternating negative 1, positive 1, negative 1, positive 1. That's fine, but the bottom will go to infinity. So whether you divide 1 by infinity or negative 1 by infinity, you will get 0, so it converges. So in this case, both converged. In the previous case, the left-hand side divergent, the right-hand side converges, meaning this one was out of the interval, this one is in the interval. The last example I prepared for you, or I got from you from online, is this. So we know here the center is 4. And then to find the radius of convergence and the interval of convergence, I do the limit comparison test where n approaches infinity. I take the limit of that of the next term, which is 2n plus 1 times x minus 4 to the n plus 1 divided by 2 to the n x minus 4 to the n, and I want the absolute value to be less than 1. This would be the limit as n approaches infinity of the absolute value of 2 x minus 4. Very simple, right? And I want this to be less than 1, which means I want 2 times x minus 4 to be greater than negative 1, less than 1. Okay, I divide by 2, so I get -1/2 is less than x plus 4 is less than 1/2. Then I subtract 4 from both sides, 1/2, and I wrote 1/4 because I was looking at the 4. Okay, and then I subtract 4 from both sides, so you get -4.5, or you can write it -9/2 is less than x is less than -3/2. Oh, oh, why did I say minus? Wait a second, oh, I didn't multiply by -1 anything, and even if I did, it would be 4 minus x. Anyway, I'm so sorry. This I will have to add 4 to both sides, so I bet many of you already got that before me. So I know that the radius is 1/2. I am at 4, centered at 4, but I can go to either 3.5 or 4.5. So if they ask you for the radius is 1/2 or 0.5. And the last step is to take each value and see whether it converges or diverges the series. So if I take x equals 3.5, I get summation n going from 0 to infinity of 2 to the n times 3.5 minus 4 is -1/2, or -1/2 to the n. Now, this would be the summation, and going from 0 to infinity, you take common multiple of, I'm sorry, common power. 2 times -1/2 is -1 to the n. Some people look at that and say, what? How does that? How does it converge or diverge? No, of course it diverges. Why diverges? Because some people will say, but isn't it going to be 1, then 0, then 1, then 0, then, or -1, then 0, -1, then 0? Why it doesn't go to infinity? That's not what we care about. We care about if there is a limit. And here the limit doesn't exist, because this thing will keep fluctuating between -1 and 0 indefinitely. So when I ask you what is the limit, there isn't. So that's why we say it diverges. So I'm going to rewrite it because it was really the interval here is -3.5 comma. And then I take at x equals 4.5, it's the summation, and going from 0 to infinity, 2 to the n times 1/2 to the n. Again, like before, this would be the summation, and going from 0 to infinity, 2 times 1/2 is 1, 1 to the n, and definitely this one will diverge because it's 1 plus 1 plus 1 up to infinity. So both sides, again, I wrote -3/2, 3.5. It's crazy. I don't know what's wrong with me. Okay, I hope I didn't confuse you with the negative sign, but again, it's a sign of old age, not positive or negative. Anyway, bad joke. Horrible, right? I'm sorry. Okay, I hope that explains to you power series and how easy really they are, how to find the center, the radius, the interval, and whether the endpoints of the interval are included or excluded. Again, if you have any questions, please leave them in the comment section or yeah, and I will get back to you as soon as I can. Until we meet again, I wish you all the best.